Which brings us to a topic that I personally feel very passionately about, and that is that I hate cursors. Cursors are evil. Cursors are a real lazy way to solve a problem when a developer can't think of the right set-based way to do it. In a future lesson, I'm going to focus right on how to optimize cursors by refactoring them into set-based code. But in this lesson, I'm walking you through some T-SQL syntax. And it's there, so I need to show you how to go ahead and use a cursor. But I'm hoping you use this only to read existing cursors and maybe refactor them, and not to write cursors yourself. In all my years of consulting and developing databases, I've never had to resort to using a cursor to solve a complex logic problem or business problem. The only times when cursors should be employed is when you're iterating through objects, doing some dynamic DDL code, like I've done inside of Nordic, the layer that I've written that turns SQL Server into an object-oriented database. Another time when cursors really scream and perform great compared to set-based code is when calculating running sums or cumulative totals, as I showed you back in the aggregating data lesson. So with that huge disclaimer right up front, which I really have to say because I'm sort of known as the kill the cursor guy, let me walk through a cursor and show you how they work. The first step of the cursor is to declare the cursor. And when you declare the cursor, you're setting up a pointer which will walk through a record set. And there's a couple variations of this that you may see depending upon whether it's a SQL 92 cursor or a T-SQL fast forward cursor. This is the most common one that I've seen. So it's declare the name of the cursor, and I'm just putting a small c in front of it for my own purposes. Data type is cursor, and here's all the options for it. And then for, followed by a select statement. This is the select statement that's going to be used to build the cursor. And the cursor will be a pointer that will walk row by row through all the data returned by this select statement. So the declare creates that pointer for the cursor and figures out the select statement that will be used for that pointer. Step number 2 of working with a cursor is to open the cursor. The open command is what actually executes the select and finds the set of data. Step number 3 is to fetch through row by row. And this is really done in 2 parts. The first time you execute the fetch, you're fetching the first row, or you're priming the cursor. You have to do this so that a row has been found and the @fetch status knows that you have one row found. The @fetch status will forever say 0 as long as it finds another row, which is why you have to find one row first so the @fetch status can begin that whole while loop being set to 0. Fetch status changes to a -1 when there's no more rows found, or -2 if it tries to go to a row that it's expecting but it has since been deleted, or it's a missing row. And every time the fetch command is executed, each column returned by the select statement, and this particular select statement only has one column returned, is placed into a variable. And the variables are simply listed out here, comma delimited, and the select statement result set is placed into those variables. So if we had another column, column 2, we would have to put that into another variable down here. Let me just Control Z to take out my edits. So to walk through the looping of this cursor, we fetch the first row, the first and last name of the first person found, sorted by order date, goes into the @name variable. And this is sort of extra, we don't need this print here. Fetch status will be equal to 0 because we found a row. And that starts the loop. We print out that first name and try to fetch another. If we find another, then it goes into @variable. Fetch status is still equal to 0. We print it out. And we just continue searching until we find the end of the data set that there's no more rows found. That will set fetch status to -1, so if fetch status equals 0 is no longer true, it ends the while loop, which closes out and then deallocates memory, deallocates the pointer, and all is set. To go ahead and execute this, and I'll open it up so you can see it. And it prints out each person found in the person table of the family database sorted by their date of birth. In the family database, the name James Halloway is used by several people. So if we actually added a suffix to it, we would see it's James Halloway Sr., then Jr., and then I think there's a third person down there. Anyways, you can go into the database and find the people if you want to. But that's how a cursor works with the 5 steps of declare, open, fetch, close, deallocate. So now that you've seen the syntax of working with a cursor, let's talk a little bit about why they're so bad. The cursor is manually iterating through each row, and you're forcing SQL Server to work one row at a time, instead of letting SQL Server work with an entire set-based query and allow its optimizer to figure out the fastest way to get the entire job done. In testing, I have found that cursors tend to be 2 or 3 times slower than a set-based, and the larger the data set, the slower the cursors are relative to the set-based solution. Think of it this way. If you have $100 you want to deposit in the bank, is it better to go there and make a single $100 transaction deposit? Or is it better to take a stack of 100 $1 bills and do 100 individual deposits, 100 transactions? Well, obviously, it's better to do a single transaction. And the larger the data set, the angrier the crowd will be behind you as you deposit 1,000 transactions. It's the same thing inside of SQL Server. If you can get it into one set-based transaction, you'll be much better off. And remember, cursors are evil.